Inner classes. What we're going to take a look at now is a special syntax for developing very focused and specialized classes in Java called inner classes. And basically what they're going to allow us to do is give us a fast way for creating very specialized classes. Now, the syntax is a little weird, and there are different types of inner classes. So what I want to do first is present to you a nice overview of the various reasons and commonalities between the different type of inner classes. Then what we're going to do is we're going to take a look at member classes. That's a type of inner class. Local classes, that's a type of inner class, and anonymous classes, and that's a type of inner class. Now, believe it or not, this nested class deal here underneath, that technically isn't considered an inner class because it has a static modifier, but it's a type of special class that's worthy of noting, so I'm going to just kind of stick it into this discussion towards the end. So as I've already pointed out, there are three types of inner classes, and they're all going to have their own unique characteristics. But why would I want to create an inner class? What does it give me? Well, the first thing that I need you to realize about inner classes is that an inner class is really a class inside of another class. And as a result, it gives me a hierarchical data model, if you will, or it defines a relationship between objects that'll be containment. For example, let's say you have an invoice and you have invoice items. Could you really create an invoice item object without ever having to create an invoice object? What if you wanted to enforce a business rule that says, look, you have to first create an invoice in order to create an invoice line item? So what you can use is this hierarchical or containment relationship, and you can use a type of an inner class methodology to go ahead and help you. Now, another thing to think about class design is you want your class design to be highly specialized and highly focused. In a previous demo, I went ahead and created a digital clock with you. And that was a class that was a highly specialized, highly focused class that anytime I wanted a digital clock to put into a JFrame, I could go ahead and instantiate an instance of my digital clock. But what if I ever want just to be able to, on the fly, if you will, create a very fast, very simple, specific purpose class that, I just need for this one time. I don't think I'll use again. Should I go ahead and create a class for it and just have it sitting out there? Well, the answer is no, is that I can go ahead and create a different type of class. Now, as I said, there are classes inside of classes. And the terminology we'll talk about are enclosing classes and enclosing instances. And here's the thing. Inner classes have some limitations. All of the three type of inner classes have some limitations. First off, when it comes to limitations, is you really cannot have any static declarations. In other words, you have to be able to instantiate them, okay? And we have some things to consider when we're naming our classes. Namely, we can't have the same name as any containing class or package. And as I said, there are three inner classes. We have member classes, local classes, and anonymous classes. All right, let's jump in with a discussion first off about member classes. Okay, let's go ahead and bring up TextPad, and let's stick with the whole invoice theme. I think that's a really good idea. Remember, what we're going to be doing now is build an instance and work with member classes and define that containment relationship. Now, before I start, let me just say that the class with the enclosing class and without any static is the member class. So this, what I'm going to define first is the parent class, if you will, or the enclosing class. Then we'll have the enclosed class. So there's really two types of classes we're going to be deal with: the enclosing class, and then the enclosed class. And it's just a little bit of terminology, but not a big deal. So here I'm going to create our first class here. So let's create a public class invoice. And I'm going to open that up. Whoops, open that up. Jump down and close it, okay? And let's go ahead and start defining some information about an invoice. And I want you to see something. I'm making everything private. Now, the reason why I'm making everything private is because I want to show you that an internal or an enclosed class has access to the enclosing classes, all of its private information. So we could have a private, like, how about private string str cust name, private, how about string str cust address, private uh, int invoice number, and let's do something cool here. Let me go up top. Let's import java.util.star package, and then I'm going to say, just to show you different data types, private date, okay, DT for date, invoice date, right? And I'll go ahead and create a constructor for it. So invoice, and we'll say that it takes a string SCN for customer name, string SCA for string customer address, int IN for invoice number, and date DT for date. So open that up and close it up. Okay, and that is going to be the invoice constructor. So we'll set str cust name equal SCN. We will set str cust ADDR equal to SCA for customer address. We'll set int invoice number equal to IN for invoice number. And then finally, we'll set DT invoice date equal to DT. All right, let me go ahead and compile that. Let me save that in C, Java / inner classes, and we'll call this invoice.java. All right, and we compile. Now, I just want to remind you of something. I want to show you the directory structure here. Let me go into my Java inner classes directory, and this should make sense. Okay, nothing too surprising just yet. Here is my invoice.java file, and here is the invoice.class file that was created. Now what we're going to do is we're going to start building the inner class. And what's important for us to see what's happening with the files that are created as a result of this inner class. So I'm going to move my cursor right on line 18 there. Please notice that here is the opening curly brace, okay, to my public class invoice. And here is the closing curly brace. So I put my cursor at line 18. I did hit enter just to give me some little bit of space to work with. And now watch what I'm going to do. I'm going to go ahead and create another class, and we'll call it invoice item. Class invoice item. All right, and let me hit enter, open a curly brace, and close the curly brace. Before I even do a thing, let's go ahead and compile now and see what we get. So I'm going to do a Control-1. Okay, now let me bring up my Windows Explorer here. And check this out. Look it. You see that invoices or invoice $ invoice item.class file? That is creating a namespace. And earlier I said there was a limitation on how you name your inner classes. And the deal is this. Your inner classes cannot have the same name as any containing class or package, because what's going to be happening is you will be having a nice namespace thing that will be building here, appended by the $. And I could put as many inner classes as I want, like inside of the class invoice, item class, I can make another inner class and another. And what will happen is the files will just append and append and append with dollar signs. So you want to make sure you see the dollar signs. And let me also add this. The Java certification exam, it doesn't really go into too much detail in terms of what they expect you to know about inner classes. But it's weird because they expect you to know about inner classes. And something like this, here, when they present, they'll show you this file and they say, identify the enclosing class or identify the enclosed class. And you'd have to know that invoice, based on looking at this file, is the enclosing class. Invoice item is the enclosed class. Okay, it'd be really good for you to be able to identify something like that. All right, so let's go ahead and build our invoice item. And we'll do a couple of things. For example, we'll do a private int line item. We'll do a private int, oh, let me correct that before we go ahead and compile. That would stink. Int line item. Private int item ID, and we'll just do one more. A private int units. All right, and this is just like really building a regular class. So what I'll do now is let's go ahead and create a constructor. So I'll say invoice item and int li int id, we'll just call it id, and int iu. Okay, and now we'll specify int line item equals li, int item ID equals ID, and int units equals IU. All right, so that's what's going on with the constructor. Then what we can do is we can go ahead and create a method. How about something like, public void show invoice. Public void show invoice. And let's see what that's going to do. So the first thing we'll do is we'll just go ahead and print out the invoice. So system.out.println, and let me show you how you can use some things. So I'll say customer name, and we'll do this. Now check this out. I'm going to explicitly refer to the invoice class's string cust name. So I'm going to say invoice dot this, because what that is going to allow me to do is explicitly refer to my enclosing instances data utilizing the enclosing class's name, and I use the this keyword to do it. So I say invoice dot this dot str cust name. Okay, invoice dot this dot str cust name. Okay, so that's the customer name for that invoice. And I'm going to go ahead and print that out. Then what I'll do is we'll do a system.out.println, and I'll do something like, let's come over here. Let me add one thing to this. Ooh, I forgot a semicolon too. So we have line item, item ID, and let me add a private string str item D description, DESC. So int line item, item ID, we'll do a string description, and what I'm going to do is I'm going to do over here, hit enter, and I'll do str item DESC equals DESC. Okay? And then what I can do is I can simply go ahead and access my information just by calling it. So I could say item description, and I'll say plus str item desc. Okay, let me put a space in there. All right, very good. Let me go ahead and compile that, and let's see what we get. So I'll do a control 1. And I get an unexpected error, and I can see that I just simply forgot a closing parenthesis. I'm sure some of you caught that over here, so let me click in there and recompile. So another control 1. And we are good to go. So that's my public class. So what I'm going to do now is I'm going to create a new file, and I'm going to call this, let's save this as use invoice, something like that. So let me do a file, save as, and I'll call it use invoice. Use invoice.java. Public class use invoice, and what are we going to do here? We're going to create a public static void main string args. Okay, now let's bomb this thing on purpose first. As a kid, sometimes I like to break stuff. So let's go ahead and bomb it. What I'm going to do first is I'm going to show you that you cannot directly instantiate an invoice item because invoice item is contained within invoice. So if I come over here and I say invoice item II, or how about my inv item, equals a new invoice item. And let's say I go ahead, I come back here and I pass all the right stuff to it. So I'm going to go ahead and let me copy this because I won't remember this. So I'm going to copy all that information about an invoice item, Control C. I'm going to paste it right there, and I'm going to change line item to line item number 1. The item ID will be 345. The description will be toy train, and the IU, which was the number of units or item units, will be 2. Okay, so I've got all the correct parameters in order to successfully instantiate an instance of the invoice item. Let me do a control 1. And here we go. Look at this. Bomb, bomb, bomb. Why cannot resolve symbol? Cannot resolve symbol invoice item. So it just doesn't like that. And unfortunately, it doesn't give me this really cool error about, oh, you first have to create an invoice before you go ahead and use the invoice item. So let's go ahead and create an invoice first. So I'm going to save, well, let me get rid of this, and we'll come back, and I'm going to say invoice, my invoice equals a new invoice. And let me see what the parameters are there. We have a customer name, address, and a date. So copy, and I'm going to say, let me paste that. And Control C that. It's a little trick I do with copy and paste so I can, go ahead and remember what I'm doing. So I have Robert Barr, and my string address is 12345 North CBT Nuggets Drive. That's my address. My IN, which is invoice number. Let's say the invoice number is 321. And then we'll put in a date in there. So let's go ahead and set up a date nicely. So let me go import java.util star. I'll just keep it simple for right now. I'll say date today equals a new date. And I'll just simply go ahead and pass today in there. All right, let me do a control 1. And we compile. Let me just verify. Yep, tool completed successfully. Woohoo. All right, so very cool. So if I wanted to, let's go back to the use Java. I could, simply go ahead and start implementing the methods there. Now, in this particular example, I shouldn't have said that because I don't really have any methods, and all the member fields are private. So I'm really kind of blocked down. The only public thing here, the only access I have to any of this data is via this public void show invoice. So let's go ahead and implement that. Now, the first thing I'm going to have to do is establish an instance of the enclosing class, which I already did, my invoice. Now what I can do is I can create an instance of an invoice item. So I can do invoice item, my inv item for invoice item equals, and now check this out. This gets a little bit different because I don't simply, I don't have the luxury now of saying new invoice item. What I have to do is I have to use this funky dot notation. And it's a chain, okay? So in order to instantiate an instance of the invoice item, I have to use the enclosing class, which I already have as my invoice. Now I say dot new. And new is an operator. It's not a method, it's an operator. So I use that dot notation. And then what I do is it's pretty straightforward now. So new invoice, and I forget all the stuff we created about the invoice. So I've got a line item. Let me just copy this. We'll fill that in. So Control C. I'll come over here. And we have an int for a line item. So this is line item number 1. The invoice or the item ID will be like, let's say, 345. A string description will be a toy train. And the units will be 2. Okay? So now I can go ahead and compile that. So I'll do Control 1. And I get an error, and the reason why I get an error is because I don't want a new invoice. I want a new invoice line item, so invoice item. All right, I'm getting a little excited here, so let me recompile that. Now, this was the error I was expecting because let's go back to the file system. You see, the file system, the classes at the root level, so use invoice and invoice can see each other. But believe it or not, this invoice item, it's not accessible just because it's in the default folder or directory with the remaining classes. This invoice item is tucked away in the namespace created by the enclosing or the outermost class, in this case, the invoice class. So what I have to do in order for my class to be visible is I actually have to import the invoice class. And by importing the invoice class, this class could take a look inside of the appropriate namespace. So now let me redo a Control 1, and we'll see that it will compile. And we successfully compile. Now, something I want to point out is that instead of using the import statement here, you could also just go ahead and say invoice dot invoice item. And we'll play more with using import and package later on. So let's go ahead now and print out some invoice information. So now I get to say my inv item dot show invoice. My inv item dot show invoice. Once again, I come over to invoice, and invoice item, the invoice item class has a show invoice class, which allows me to print the customer name and the item description. Remember, everything about these classes are private. And notice how the inner class here, the invoice item class, has total access to everything that's going on in the enclosing class. So let me do a Control 1. And now let's do Control 2. And here you can see that it is printing exactly what we want it to print. So that is using member classes. Now what I want to start doing is turning our attention to something called local classes, the second type of inner class that we're going to talk about. Local classes differ from member classes in a couple of ways. First of all, local classes are declared within code blocks. Well, what are examples of some code blocks? How about methods? For example, like the main method. As a matter of fact, you can see within my main method here, I went ahead and declared a local class. Constructors. Here's a constructor. That's a code block. I didn't put a class in there, but that's a code block. We also have several other kinds of code blocks like static initialization blocks and instance initializers. Now, local classes have some pretty cool things to think about. In terms of the visibility, a local class is only visible within the code block where you've defined it. So in a sense, local classes act like kind of like local variables. And you can only use final method parameters or final local variables that are within the same scope. So if I wanted to implement some other variables from the main method inside of here, inside of the invoice item 2, they'd have to be final. They can access, they have the same kind of access to member data and methods of the enclosing class, similarly to our member classes. And you cannot declare your local classes to be public, protected, or private. And the biggest utilization for local classes will be in event handling technology and Java programming that we're going to talk to a little bit about. So what am I doing here? Well, I just hacked up a little bit our previous invoice example. I went ahead and created the public invoice2 class, and I put private string in there. As a matter of fact, I decided not to use that, so let me thin this out a little bit. So I created an invoice2 constructor that takes a string cust name and a string cust address, and it simply prints those out. Then in my main method, I instantiate an instance of it, passing to it a name, my name, and my address, 1234 CBT Nuggets Drive. And then inside of here, I create a class invoice item 2. And in order to instantiate that, you pass in an invoice item number like 345 and a description of a toy train. So that goes ahead and compiles just fine. And let me do a control-2 to run it. And here we can see that I've got my name, my address, my item number, and my description being printed out. And that's using a local class, which is a class declared inside of some kind of a code block, like a method or a constructor. We're going to become extremely intimate with local classes when we do event handling, meaning making things like buttons click and whatnot in Java Swing programming. Another thing we're going to use a lot in event handling is going to be utilization of anonymous classes. Anonymous classes are a little bit weird because they have a really way off syntax, but we're going to get used to them because we're going to be using them a lot. So let's just take a look at this example first, and when we get more into event handling in Java, we'll get a lot more practice using them. Now the thing that I want you to notice is that anonymous classes do a couple of things at the same time. You see, what they're doing simultaneously is basically defining a class, and they are instantiating an instance of an object. So that's why you can see, look at this. Here I'm defining a class and instantiating an instance of an object. I've got class chocolate. Class chocolate has a method void eat. Simply says I love eating chocolate. Here I've got class food. In it, I'm instantiating a new chocolate called chalk, and notice the open curly brace. Well, here's what's going on here. If this is a name of another class, which in my example it is, okay, chalk is a chocolate, then all of a sudden I'm going to automatically be inheriting or extending from my anonymous class. If the name is an interface, then I'm implementing that interface. So basically what I'm doing is on the fly here is I'm overriding the void eat method in chocolate because this chalk is now inheriting from that in terms of the food class, okay? So a couple of things that we need to know about methods of local and anonymous classes. One, you can only be declared in the method body, declared as parameters to methods, declared as final in the local classes enclosing scope, and then declared as fields in the enclosing class. And as I said, I just wanted to kind of give you a preview of this because we're going to be using it a lot more often when we get to working with event handlers. Finally, we're going to talk about the other case, the nested class. Now, any kind of a class that you define implementing the static, okay, using the static keyword, and it's a member of another class, is considered a top level class. And the reality is they're not really considered inner classes because they're not as limited as inner classes that we've talked about already. Check it out. Here I've defined a public class invoice for, and in it I've got static class invoice item. And I went ahead and created a constructor for it. And the syntax that I use to go ahead and instantiate an instance of it, I can do a couple of things. I can use the dot notation where I instantiate an instance of it by fully qualifying myself, like invoice for dot invoice item, my item equals a new invoice for dot invoice item. And this syntax is a lot different than the member classes that we took a look at earlier. Or I could utilize some packaging techniques too, using an import statement. Now, interfaces that you might define within a class are going to automatically be static and therefore considered this top level. You can't have an interface only nested top level interfaces. And if you go ahead and declare an interface as static, you can do it, but it really doesn't give you the effect of anything. It's kind of a useless thing. So if I go ahead and run this, you'll go ahead and see that I'll get 345 and the fact that I have my toy train, and that's coming from inside of my nested class here. In inner classes, we took a look at some syntax that Java gives us in order to define kind of relationships between objects like hierarchies or object containment. We took a look at member classes, local classes, and anonymous classes. All these three are really considered inner classes, but this one is kind of special because of the static keyword, and that was the nested class, and it doesn't have any of the limitations that normal inner classes have. We're going to be using a lot of this information, specifically what we learned here with local classes and anonymous classes, throughout the rest of this course when we get into working with event handling. So I just wanted to present this to you first before I start working with it in a little bit more detail. I hope you have found this informative, and I'd like to thank you for viewing.